Day 2, last presentation, and finally we go into unstructured data. I was waiting for that. We have Mehul here from Aryn, and they have a solution where they say, okay, we take unstructured data, we do not only provide search on it, but also enable you to create analytics based on that unstructured data in an easy way. So really looking forward for the talk.
Thank you, Matthias. That's actually a really concise explanation. So I know on the title slide, just quickly, I'm Mehul Shah. I am the CEO of a company named Aryn, and I'm really quite humbled and honored to be here speaking to a bunch of people in the search relevance space. It's a community that I'm not familiar with, but you guys have welcomed us with open arms, so I really appreciate that. And I think what's happening in the world out there today with LLMs, I'm coming here to a community that knows about search extremely well, and I hope to convince you by the end of this talk that it's time to kind of open up your horizons and open up your minds and think more broadly about search, and in particular on how to do analytics over unstructured data. A little bit about us. What we do is we make it really easy to use a variety of generative AI models, a variety of models altogether, and make them conspire, if you will, to allow you to analyze all the unstructured documents and data that you have in your enterprise. And the thing that our system does really well is allow you to scale and get accuracy at scale. Okay. Our background is in data, databases, ETL, search. We have a founding team from AWS. I used to be the general manager of the OpenSearch service. That's how I know many of the people of you over here. We also have people from Google and Meta. We're real big fans of open source. That's why we're here, in the Open Source Connections conference, right? So we were founding members of the OpenSearch Software Foundation. We contribute yearly for the first year and multiple years after that. Part of the governing board here, and also we have members on the technical service committee there. And finally, we've been funded, so we've got some money, so we can actually run for a little bit and solve some real big customer problems, funded by some key investors in the Bay Area. So I don't really have to go into a deep introduction about unstructured data in this audience. I'm pretty sure you guys know the relevance of unstructured data in enterprise and how much information there is. And certainly for the past 30 years, y'all have the best tools out there, for dealing with unstructured data, and that's been search. It's been our most effective tool. Okay, but in comes these large language models, generative AI models, and over the past 2 years, they've really made a ton of progress, just tons and tons of progress. Now you can take these LLMs and just pick them up, prompt them, okay, and get state-of-the-art results without an AI team around you, without a lot of experts around you. They can do a variety of things like summarization, entity extraction, sentiment analysis, okay? And so it seems like it's worthwhile using this wonderful piece of technology and bringing it into the search world, which has been building on a bunch of technology as well for dealing with unstructured data, and bring the two together. One more thing has happened over the last 2 years that I think we should be paying attention to. The graph basically shows you the price of a GPT-4 class model, and how that price has dropped over the year. It's literally, in that graph, it drops 2 orders of magnitude, okay, last year. So about 100x cheaper now than it was in January of 2024. More importantly, these models are also getting 10, 20 times faster than last year. So you look at companies like Grok, Cerebras, and so on, their retail performance on their APIs is something like 1,200, 1,500 tokens per second. And that's just their retail performance. If you actually go and try to buy one of their boxes and run it, you can literally get millions of tokens per second in terms of performance. So how you use these LLMs, especially around unstructured data, the first step that we took as a community was let's take the LLM and we stick it at the end of our search pipeline, okay? And then we called this RAG. Honestly, pretty good idea, right? Pretty simple idea. It's the simplest ideas that actually have the biggest impact. But I want to offer you a different perspective about RAG. And that's the perspective that I've seen a lot of people take, where it's much more general. right? And the way you think about RAG is it's a new computing paradigm. Okay, you're not computing now with GPUs anymore. Sorry, with CPUs anymore, and operating systems. Your LLM is the new operating system. Okay, and it's like going back into the 1950s and 60s and thinking about building applications. You have this, very constrained environment in which you're going to be building an application, and in this case, the constraint for an LLM is the context that it has. So the main memory, effectively, of the LLM. And we can talk about LLMs. I know there were a bunch of questions in the past or in other talks here where they said, what if we have infinite context? Look, reality is that the longer the context, the less attention you pay to the whole thing. So there really is a sweet spot for all the LLMs out there where the amount of memory it's using, you can actually get accurate results. So think of the LLM as effectively a new computing paradigm. Okay, and what RAG applications are doing is they're taking search and taking the top K results from those searches, whether they're BM25 or vector indexes or whatnot, and then they're filling in the context, passing it in, right? So it's like programming in the 1960s, right? And then asking the system to give you an answer. And that really works well for a lot of use cases. And it's not easy to get it right. There are books written on it, thanks to Trey over here and a bunch of other people, right? It's a really hard thing to do, but you can do so much more, right? It provides, what it does is gives you a natural language interface over your data, but the answers that you get effectively are limited by what's in the context and how you shuffle things in and out of your context. So the question is, A, do we need to do more? And two, if you do need to do more, how do you do it? And so our answer, of course, is, of course you need to do more. And where we learned that was by working with customers, enterprises. So we have customers in a few verticals, in financial services. We have customers in pharmaceuticals. You have a regulator as a customer that wants to do legal analysis. And all of these analysts, what they want to do is more than search, right? Their job is actually, it's a more complicated task. It's usually a research task. And what they typically have is a collection of documents with a common, what I like to say, a common theme, okay, a common semantic theme. We'll call it a semantic schema, if you will. What I mean by that is, you have things like earnings calls. They roughly have the same kind of information, but the layouts are different order. Filings to the SEC, for example, investment memos, or if you're a legal analyst, you're looking at legal judgments, legal memos, legal filings of those type. For the pharmaceutical company, the marketing analysts that are looking at this data, they're looking at thousands and thousands of interview transcripts with their doctors and their insurance providers. And what they want to do is they want to ask and do tasks where you have to kind of, go across your corpus, pull out information from each of the little individual pieces that you have, and then, synthesize a result. And it's not just a single question that you're going to ask. You're going to probably do repeated analysis over and over again until you find the insight that you're looking for. So it looks a lot more in terms of the patterns that you're looking that you're running over these things. It looks a lot more like analytics. And today, this is exactly what they do. They use a search engine to find the things that they're looking for and then manually do the analytics. And this is really painful. Okay. And so we think there's a need to go beyond RAG, and we're calling this deep analytics. It's kind of like deep research, right? But what you're doing is you're running basically database style plans over your underlying documents. And there's sort of three classes of analyses that people want to do. RAG in some sense a subset of that. So RAG typically is a hunt and peck type operation. If you've got a big document collection, you're looking for a few facts in that document collection. What was the capital expenditure for Google in Q4 2024? There's maybe a couple of documents that have that information. It's complicated figuring that out. You actually have to know how to read the tables and pull out the information. It's not in a single line. But it's a hunt and peck type operation. But there is also sweep and harvest type operations that people want to do over and over again. And you kind of have to do the sweep and harvest from all the board decks and investment memos. I want you to summarize the capital outlays of all the top companies by ARR in the construction engineering market. And so now you can start seeing how this doesn't really solve, like RAG just doesn't solve these problems. You really need to take your LLMs, or people, if you will, because that's what LLMs are simulating, and permeate that through your workflow. So in this case, you're doing an extraction of the ARR as well as the market for each of the companies you might have in these board desks and investment memos. You're going to obviously want to filter this down to only the construction engineering market, sort by ARR because you only care about the top ones, and then find those documents and summarize the capital outlays. This looks like a database query plan. It's a workflow. Also, other workflows that we've seen through our customers are things where we're integrating and synthesizing information across multiple document collections. And so this is what we're solving with Aryn. We're building a new category of AI data systems. We're calling them agentic unstructured data warehouses. Okay, you put in your document collections, your document sets, if you will, and data warehouses do three main things. They allow you to transform your data. They allow you to do ad hoc analytics, and so we're calling that deep analytics on your complex documents and your structured data. And they allow you to do reporting. And I'm happy to announce today that the Aryn platform is available in public preview in the cloud service. Go ahead and take a quick little picture of the QR code over there. That'll tell you how to get started. You can get started for free, upload your documents, try it out. And obviously it's early days, it's public preview, but we'd love to get your feedback. Okay? Can everyone get that? Yeah? All right, great. And so this is what the Aryn platform looks like, right? We've got document parsing as sort of the first step in the platform. And the document parsing step we call doc parse. And what it does is it basically takes your underlying documents, extracts all of the information from those documents, things like images and tables and text, and labels them in sort of variety of different label object types that we have, and just breaks it down to its constituent components. And then we index all of that stuff in OpenSearch. It's the open source platform that we love. We can do it also in Elasticsearch. We're trying to be agnostic to these things, but OpenSearch is what we know the best. And then we have a agentic reasoning system that we call Deep Analytics, or our internal name for it is Luna, that allows you to take your questions and turn it into these sort of complex plans that run over your underlying data sets. And all of the ETL that we need to do, all of the data flow processing that we need to do, all of the analytics that we need to do over this unstructured data is done with a layer called Sycamore, which is also open source. Okay, and so let me kind of dig in and show you the whole system, see it in action end to end, and then we can kind of dive deep and see how each of the pieces actually conspire to make all this stuff work. All right. So at the core of any sort of data warehousing system, you need some main data structure. And the main data structure that we have within Aryn is this data structure that we call a document set. Kind of like a table, except instead of rows, you have documents. Okay. So in this example, or in this demo, I've loaded up a few hundred documents from the National Transportation Safety Board. Let's pick a document that's actually has got a lot of stuff in it so that we can kind of show you all the features of the platform here. Sorry for the delay in the downloading of the document here. Okay, so here's a document that has images at the top, tables, sort of prose or free-form text here, more detailed images. And so you really want to be able to pull all these elements out. So the first thing the system does when you kind of load it in is it decomposes these documents into their constituent components. So this is an image up here. Here's a table. And we actually get down to the individual cell level. So we have our own sort of table models, our own segmentation model to actually break these things down. Here's the text. We have a variety of OCR models, and I'll get more deeply into that in a few slides. And we can also pass images. We actually do this on a regular basis to VLMs, so you can get a summary of the image in English. And so this is useful for indexing all the information here. So we break them down to their constituent components. And then we index all of these elements that are in your documents. We create embeddings, reverse indexes on these things. And the other thing that we also do, and this is really important, is we pull out key properties that you're going to want to query over. What we found is, the better you do at pulling out this kind of metadata, the easier it is to get accuracy on the tasks that you have. And so we pull out metadata that you tell us to pull out. For example, you can actually click extract here and type in a new metadata item, and we'll go through your documents and pull that out. We also can pull out metadata that LLMs recommend given a sample of the data that you have. And so, not only are we pulling out metadata, for example, things like aircraft and, what time and location, things that you see in the table up here, but we're also pulling out metadata like, what the cloud condition was, or, whether it happened day or night, what the temperature is. Not all of this information is actually sitting in tables. It's actually sitting in the text in free form. Okay. So you load all this stuff up, and then you can go into our workspace. And the workspace basically gives you a natural language interface over to do deep analytics over your underlying documents. So here's a very simple question that we're going to ask. See how it works. So you type in the question. In this case, it was pre-populated. And the system actually uses an LLM, and I'll show you how all that stuff works, but uses an LLM to create a plan, just like you would if you were using deep research with OpenAI or Perplexity or Gemini, except the plan here is a data flow plan. Okay, it's not steps one by one that you're doing where you're fetching stuff from the internet, but really data flow that you're going to be running through OpenSearch and a bunch of different filtering steps and extraction steps and summarization steps that you'll do over the data that's coming through. So in this case, what incidents occurred in July 2024 involving birds, we could use a vector search for this. We could use a hybrid search for this. What we find, though, when you're doing something like this, when you have very specific metadata fields in there, like July 2024, and you're looking for very specific things, semantic search actually tends to fill in a lot of sort of false positives in your top K. And so what we do here is the system automatically figures out, for example, that we should be using the date time field to go get July 2024 records, and then we get each of those records and we pass them through an LLM filter, which will look at each document one at a time and run this prompt. Does this document contain an incident involving birds? And so you actually get exactly the right answer out of this data set, which is these two particular documents. Let's take a look at one of them. Load it up, and you'll see that the defining event was a bird strike and an in-flight collision with a bird while flying in an airport traffic pattern. Okay, so pretty simple, but this is something that you couldn't really, people talked about this in the last couple of days. Let's use an LLM to go figure out what the filters are, but what filters to use. But this is something that you wouldn't really think about doing in search back in the day, because if you had lots and lots of metadata properties, it would just confuse the user. Now, the user doesn't actually have to know about the metadata properties. All they need to know is that there's a way to translate their question into the metadata that you have, which then can get you very specific and more precise answers. And this really works well. With some of our customers, we can get this stuff to work extremely well when you have millions and tens of millions of documents where vector search and semantic search start breaking down. Okay. What's another thing that you can do with a system like this? Well, imagine you want to ask a question like, what were the most commonly damaged parts in incidents involved in Texas? Now, damaged parts, this is information that's in these documents, but we didn't pull that metadata out. Okay. And if you really want to know all the various damaged parts that are in there, again, if vector search isn't really going to pull this out, or if it does pull it out, it's not clear that you're going to be able to put it all into the context of an LLM with a RAG style pattern. Instead, what we do here is it comes up with a path here. I'm just going to run it so you can see it while it's running. Pulls out all the Texas documents. It's going to create a new column, a new property. Sorry, it went faster than I thought. It's going to create a new property from the text that says, give me the list of damaged parts. Okay. And then there's an operator here this part is an LLM-based operation. So you can actually run an LLM with the prompt that's going to extract this per document. And then you're going to push all this thing into another LLM operator, which does some grouping for you and then counts. And so you'll see that there are, something like 4 4 plus 4, 8 different documents in here, and they break down, based on various categories here. And one particular category here is destroyed, so apparently the whole airplane was destroyed here. So if you wanted to actually figure out what was going on and in the grouping that it was doing and what actually came out, the other thing that the system does is actually keeps track of the output at each step. And you can actually dig into the output. So in this case, I'm digging into the output of the second step, where all it did was pull out the damaged parts. And what you see here is right wing, fuselage, engine mount for each of the damaged parts for each of the documents that we pulled out. So here's the item that was destroyed, for example. Okay, so cool, right? You can not only understand, you can not only get the answer that you're looking for, but you can get an explanation of how that answer was produced. You also get an ability to kind of follow through, to be able to see, where this information came from. So are you going to get this right 100% of the time, all the time? Absolutely not. It's an interactive product, so sometimes it's going to be wrong, but hopefully you'll be able to look at the plan and say, hey, this isn't really what I wanted. Change the plan. You may be able to look at a particular document, realize, hey, this isn't really what I meant. Change the question. But you'll get this sort of interactive approach at analyzing your documents, where you no longer have to do this manually, which is what most people do today. Okay, let's do another example here to kind of show you another cool feature, which is list the incidents. Actually, let's try something new. I've never tried this. So, which states in the Midwest were most affected by aviation incidents in July? Okay, so let's do something even simpler. List the states. List the incidents in which that occurred in the Midwest. So I just want a list of incidents that occurred in the Midwest. Midwest is defined by some amorphous property. Maybe, LLMs know what the Midwest is. Maybe you have a different definition of it. Let's see what this thing does. Okay, so it looks like I don't really know what this thing is going to do when it's going to pull this stuff out. So I want it to be much more explicit. So I can actually edit the plan. I can say, please enumerate the Midwest states in the plan. Let's see how well that works. So we have the ability to edit the plan if it doesn't come out the way that you want it to do. Right? So now it's going to enumerate this. Does this document describe incident that occurs in these states? Oh, wait, I think of Texas as being part of the Midwest state. So let me edit the plan one more time. Please include Texas. And this ability to kind of iterate with what the system is doing without necessarily having to type code in anymore, this makes it available or accessible to more of the sort of tech-savvy analysts that are there, but they're not necessarily folks that are going to be writing OpenSearch queries, Python, or even SQL. Okay, so it added Texas in here somewhere, I think. Did it? Oh, it did it in the first one. Okay, hold on. No. Did it? No, but I want it in the list. Well, it's in the prompt. So let's run it and see if we get Texas or not. Okay. By the way, this is totally, completely live. In other cases, it actually enumerates it as a list and passes it as a filter inside of OpenSearch. So there are ways to kind of instruct this to create the plan that you want as you kind of get used to the system. So we can run this. It's going to take a few seconds. And as it's running, it can kind of show you the documents that are kind of coming through. So let's see. Should be about like 20 docs or something like that. I'll see if I want to wait for the whole thing before we get on, but it's worth kind of getting a feel for how this thing works. As it's going through, more than 11 docs. And, we have a bunch of stuff from Florida and Maryland, but that's the source. So hang on. And you can see it included Texas. All right, so it's actually doing the job. It'll take a few more seconds to completely finish. But you can kind of get the gist of how this works, right? And then the The other feature that we have, for example, is once this is finished, what you can do is you can label these things as bookmarks and then use them as the input for the next step. So here, I'll give you an example up here. Actually, let's kill this thing. Try a different one that's a little bit faster. Oh, I think it might be done. Doot doot. All right, let's not wait too long. List the incidents in Florida. Oh, there's another cell running. It really doesn't like this. Okay, let's run this plan. Let's run it again. Okay, this will get through. So here are all the incidents in Florida. So another feature that we have here is that, let the AI overview finish. There we go. We can label this as all the incidents in Florida. Becomes a bookmark here at the top. Okay. And then you can go in and you can say, which of these included Piper aircraft. Run it. And then now the source isn't the original document set, but it's this intermediate data set that you created. Okay, and we can run this. So I can go on and use up the rest of my time showing you demos on this stuff. But let's talk about how actually all of this stuff works underneath the covers. Okay. Go back. All right, so there's three main things that we did here. One, parse complex documents. Two, basically create pipelines for enriching those documents and indexing them, and then converting the natural language queries into execution plans that we run that are explainable. Okay. So I want to kind of walk you through those steps. With Aryn doc parse, we actually don't have a single model, but we actually have a collection of models that we run through. The first model that is in this pipeline is one that is a custom segmentation model that we built. It breaks it down into 11 different types of objects in your documents, and then based on the type of object, we'll run different extraction models. So we'll do run different types of OCR. We might actually pull the text out from the PDF if that's actually pretty easy and clear. We'll use vision language models for images. We have a custom table extraction model, and then we have a whole ton of post-processing that we do with the underlying sort of Sycamore platform data pipelining system that we have. And these new custom models are ones that we've built ourselves based on publicly available information as well as permission data from customers. And it's based on the deformable DETR architecture that comes from Meta. It's one that was used for image processing, and we're using this for documents. So we turn every document into an image, and then we run it through this pipeline. So it's a really popular method. We've built our own, so it gives us much better accuracy than sort of many of the other folks that are in this space. That's what this table on the left-hand side is showing. Just on the segmentation task, we're about 1.5 to 2.5 times better. And in terms of results on various RAG benchmarks that we've built, one for our internal benchmarks for our customers, one for an external benchmark from Finance Bench, we basically can get state-of-the-art results. And it's largely from doing a much better job of extraction from the underlying documents. Okay, so let's talk about Sycamore. Sycamore is a scalable agentic data flow system. Okay, the reason I'm calling it an agentic data flow system is because these LLM-based type operators, they're acting as agents. They're not doing everything. They're doing something very specific, and that's what brings up the accuracy of the system. It's doing either extraction, or it's doing filtering, or it's doing summarization. Right? It's not doing 100 different things. And by kind of stuffing a context and having it do a bunch of different things, you actually lower the quality of the output that you get. And what we end up doing is actually building these various agents and sticking them together. With Sycamore, you can write programs very much like how you would write programs in Apache Spark with data frames, except instead you use doc sets. And you use that as a way of kind of pipelining different transforms, enrichment operations, as well as doing analytics with it. And Sycamore, of course, is also open source, Apache v2 license. And you can go to the GitHub here, take a picture of this and download it and run it yourself if you want. Okay. We actually had a workshop on this. Henry and John did a pretty good job of explaining how all this stuff works there. At the core of Sycamore is, again, doc sets. Doc sets are collections of documents, and the document model we have is actually quite general. The documents can be hierarchical. You can have sections within documents. Sections can have elements. And then for each, and so these things are represented as trees, and each node in the tree can have arbitrary key value properties that you can pull out from them. And then you can use those properties to, appropriately transform the data that you have and then load it in and analyze it in a variety of different systems. We are using OpenSearch here. Okay. Sycamore has a variety of different operators that we support. You saw some of them in the plans. We have structured operators for querying database, for filtering, grouping, aggregation, or running an arbitrary map over all the elements that are there so you can reduce the data set that you have or transform it. We also have semantic operations. So these are LLM-powered operations for doing vector database queries or filtering, extractions. They're basically the analogous ones to the structured ones, except you don't have to pre-do the ETL here. The ETL is happening sort of naturally in the in line. Okay. Here's what a Sycamore script looks like. Here's example, for example, a Sycamore script that's going to pull out metadata for you. You describe the schema at top. You describe the LLM that you're going to use, and then you start using document sets by pointing to the data that you have and using dotted notation to run your operators. So you're doing the first step here, you're doing partitioning or parsing. Then you're doing extraction of the schema, and then you can take all these elements and explode them and compute embeddings and then store them in your destination. All right, so let's go over to deep analytics, right? How are we actually creating these queries? Internally, the planner that we have, we're calling it Luna. And what it does is it takes these natural language queries and it converts them into an execution plan. And it's actually converting it to a logical plan, okay? And that logical plan, then we apply a bunch of different rewrites and optimizations to turn it into a physical plan that gets turned into a Sycamore script that runs over your data. And the thing that we learned here is use the same framework that you're using for ETL for doing your analytics, because often the same operators are necessary for both. Okay. And so the Lunar planner is actually getting more and more sophisticated over time, but the basic structure is the following. You create a prompt. You tell the system, hey, you're going to go turn this into a plan. Here's the schema and the information about what's in there. Here are the operators that you can use, and I kind of enumerated all the operators that were there. You give them a few examples, and then you give them, you give the LLM a bunch of different questions that come in, and it actually does a remarkable job of creating plans that actually work. And here's one of the plans that I demonstrated to you, which is the most commonly damaged parts in Texas. Quick little summary of a benchmark that we ran. Okay, created a benchmark on these incidents, about 30 different questions. No cheating here. We actually just ran it, looked at the results, and just out of the box, we got 66% correct. Right now, we're not doing retrieval here. We're doing analytics, so it's a harder problem. The other things that we didn't get right are actually fairly easy to fix, fairly easy to identify that they were wrong, and by editing the plan, by giving the LLM a little bit more instruction, you can pretty much get all of these right. Okay. All right. So some parting thoughts. I think the most important thing here is for this stuff to work, right? You're not replacing the human. You're accelerating what they do. Okay. And to make that work, you really have to make things explainable and allow the human to iterate, especially for the deep analytics part here. And I'm going to use a quote from Terence Tao. Right? It says that he kind of said this in many different ways. AI are incredible guessing machines. And the most successful application of AI has been when the output of AI is independently verified. We've done this for protein folding. We're doing it for gameplay. Most common use of this, we know is in creating code that people are, software engineers are creating for their normal process of, development and, deployment. And we already have a sort of a workflow in programming and software development for testing that the code that you create is correct. And so this is why it's been so successful. Now, if you're doing this for analytics, imagine you ask a question, how many planes crashed in the Mojave, and you get an answer like 21. It's not very useful unless you're able to inspect the plans, look at the data, and then follow up and ask questions in different ways to build trust that that's the actual answer. You might look for cities that are near the Mojave Desert or in the desert, and just make sure that you can, the sums and the things tabulate up well. So you have to be able to ask follow-up questions. And if you can do this, we think you can actually create a successful deep analytics system. And we're already kind of starting to see this in other contexts, for example, in deep research. So I want to conclude here and then ask you guys to ask a bunch of questions. And for anybody that asks a question, you get a little duck. Okay, this is the prize. But I want to conclude here by saying sort of three main things. Right? I hope I have convinced you that generative AI now is possible to unlock a whole bunch of batch AI use cases in an interactive fashion, because LLMs are getting much faster now. They're much more accurate, and they're much cheaper. And users want to do so much more than just search and retrieval with RAG. And hopefully, broaden your horizons to think, hey, maybe this is the future. Like, there's a lot more of this that's going to be going on. Our approach to this is deep analytics. Okay, you can use these techniques in other places as well. Our approach is deep analytics, where we use agentic reasoning to create plans that are a combination of database-style structured operations and LLM semantic operations. And there's clearly a lot of room here for optimization. Okay? Tons and tons of room. And we're working on some of these things. And finally, verifiability is critical. We've just scratched the surface here with the ability to kind of trace what's going on, having a human in the loop. But there's much more room to make that much more concise and easier to follow, and more practical in very specific settings. So with that, I welcome you to try it out. There's the Aryn AI website. Go to the GitHub for Sycamore, and I welcome your questions. Thank you.
Thank you. In old tradition, I start with an online question. Dipanju would like to know a bit more about what parts of Aryn are actually open source and where the parts are that are proprietary.
Sure. So what's open source and what's not, because sometimes that can get confusing. I think if you take a look at our data flow system for doing both ETL and the query processing, the underlying engine is Sycamore, and that is entirely open source. Okay. The storage that we're using is OpenSearch. We can't change that. I already changed it once. We don't want to do it again. That is open source. Okay. We do have various models for doc parse. The segmentation model, for example, we released an older version of it, and that is an open source. The entire sort of system around document parsing with all the various specific models, it's much more complicated than that, and we've kept that closed source. And then the agentic reasoning system that we have that turns things into query plans, that is also closed source. So different pieces of this are closed. Most importantly, if you just want to go and build on the basic infrastructure that does the ETL and the query processing, that's Sycamore. That's open. There's the QR code. Go download it and try it. And then all the other pieces, feel free to reach out to us. They're available in the managed service. A lot of it is free. We want you to experiment with it. Go ahead, Eric.
You might have partially answered my question, which is, can you tell us more about the query planners? I mean, it seems like that's maybe part of the special sauce or the key bit to making it work. I don't know, what can you share about them? I've heard query planners a few times this week, and I'm curious if it's an area of like more innovation and importance than maybe in the past.
I believe query planners in this space are gonna have a ton of technology around them. We're just scratching the surface. And it is not open source because there's a lot of stuff there there's a lot of stuff that's built up not based on any one particular technique, but a bunch of experience that we've had with our customers. And so our mantra has been, things that are based on sort of well-known techniques or techniques that we publish, we also make them open source. But things that are based on experience that we have with our customers that are kind of built in, we'd like to keep that in, make money off of it, because that's our special sauce. And the prompts that we're using, there's a bunch of special sauce there. Trying to tell it how to generate the logical plans, and what intermediate language or IR to create the logical plans in that we can then turn into Sycamore plans. There's a bunch of variety of choices that you can make, and we've chosen one. I'd be happy to tell you what those things look like, but there's a lot of details there that I don't know. I mean, the technical folks don't. But I do believe that there are going to be even more sophisticated ways of doing planning, as the use cases that we run into and we expound on, require more and more technology. I will say one thing. Initially, the planner required a lot of different examples for it to work well. Okay. If you're asking a question like this is what the plan should look like. This what we've found ways to make that much, much cheaper, where you don't need a lot of examples, but it relies on how you create the IR, intermediate IR. So sorry, I can't tell you more than that. Right? Which one? Duck.
I totally needed a new duck, so
Okay, all right.
I had to ask some kind of question.
Go
And
ahead,
if I
John.
missed this, I apologize.
No problem.
So to what extent, how do you balance between sort of query planning, editing the plan, and the conversational history? Like, to what extent does conversational history come in as context, as part of the planning or as part of the overall?
Yeah. So we actually originally didn't have many controls in the system. We just did it the way sort of ChatGPT does it or Gemini does it, and we found that actually confused the system a lot. The history actually screws things up a lot. You'll ask a question, you really want it to plan, and instead it just decides to take the answer from the previous question, right? And so we actually cut out the history. And that's specifically the reason why we brought in bookmarks. So bookmarks basically are a way of telling the system, please only use the history that I care about, the stuff that I got from the Florida incidents, for example, and so on. And so we don't use history that well. Now, in terms of balancing between, planning versus automatically picking up stuff, for the most part, the system right now is pretty simple. You get to do you get to decide what your input document set is going to be. The output is going to be a document set, and then you're going to get an AI summary of the document set that you have. And that's how we've kept it. And that seems to work pretty well. It gets you pretty far. Here's the duck. There you go.
Okay, I think we have time for one more question from Rahul online. Are you using the LLM to extract metadata out of the documents?
Yes.
And here's another question. What is Luna using to break down the query into a plan? So a lot of people interested in the query plan.
Yeah. So absolutely, LLM extract is using LLMs. LLM filter is using LLMs. LLM summarize is using LLMs. We're using a variety of different LLMs. We can use OpenAI. We can use cheaper models that OpenAI have, like the mini models. We can use Claude. We can use Haiku with Claude. Just your mileage is going to vary depending on the model that you're going to use. You can use open source models. For planning, we actually just use OpenAI's, I think we're just using 4.0. Okay. So we're not using one of the cheaper models, but we're also not necessarily using any of the reasoning models. And 4.0 basically creates an intermediate representation, as I mentioned for Eric. That intermediate representation is then turned into, a semantic, a Sycamore plan. The intermediate representation is actually in Python, if you want more details. But exactly what that IR looks like, I don't, I can get into it offline.
Okay.
Yeah.
Yeah, we have a few more questions online, but I would say they can contact you
One
on.
more question over here.
I do have a question. Yeah.
Yeah, let us have it, and we'll let people go after that.
Yeah, no, we are at time. So
Oh, okay,
my sorry.
No
So my suggestion would be to contact Mehul via relevant Slack. Are you on the?
Yeah.
Yeah. So if not, I can get you in touch with the people and the questions.
Yeah, absolutely.
And yeah, thank you, Mehul, again for your talk.
Thank you all for coming, and look forward to chatting.
We have some closing remarks in the other theater.